dividend as before, but 2 new divisors. And both of these are 2-digit divisors. In this first problem, we could start by asking how many 24s will fit into 5. But since our divisor now has 2 digits, we already know that no 1-digit chunk of the dividend will be big enough for that to divide into. So, because we have a 2-digit divisor, we automatically need to group the first 2 digits and ask how many 24s will make 52. This is trickier because multiples of 24 are not on our multiplication table. Instead, we have to figure it out by estimating or good guessing. Because we know that 2 times 25 would be 50, 2 is a really good estimate for the first digit of our answer. 2 times 24 is 48, and then when we subtract 48 from 52, we get a remainder of 4. Okay, so far so good. We've already dealt with the first 2 digits of the dividend, so now we bring down the last digit to join the remainder and ask how many 24s will make 48. That's easy, it's 2 again, because we just saw that 2 times 24 is 48, so that will leave no remainder. So the answer to this first 2-digit divisor problem is 22. Now let's have a look at the next problem. It's also got a 2-digit divisor, so we'll start the same way. We'll start with a 2-digit chunk of our dividend and ask, how many 88s will it take to make 52 or almost 52? Uh-oh, see the problem? Even though both are 2 digits, this won't work because 88 is already greater than 52. And that means we're going to have to take an even bigger chunk of this dividend. We need to group the first 3 digits together. But that's just like doing the whole problem at once without breaking it into any steps. Yep. And that's why division problems with big divisors can get difficult. When you have a 2 or 3-digit divisor, each step might be as big as the whole long division problem, and it can take a lot of trial and error to figure it out. In fact, if we had our way here at Mathantics, when division problems get that complicated, we'd just let students use calculators to solve them. What do we want? Calculators! When do we want them? Whenever we have long division with 2 or more digit divisors! Okay. But what if we don't get our way and you need to solve this problem without a calculator? What's the best strategy? Well, a little estimating will help us make much better guesses at our answer. The numbers 88 and 528 are kind of hard to work with. But if we made estimates of those numbers, like if we changed them to 90 and 500, that would make it easier to estimate the answer. Since 100 would divide into 500 exactly 5 times, that means that 90 will divide into 500 at least that many times. So let's make 5 our first estimate for the answer. To check to see how good that estimate is, we multiply 5 by 88 and then subtract that from 528 to see what the remainder is. Now, 5 times 88 is kind of tricky on its own, so you may want to use scratch paper to work it out. 5 times 88 is 440, and when we subtract 440 from 528, we get a remainder of 88. Looks like our estimate was too low. Whenever the remainder is greater than or equal to the divisor, it means we underestimated the answer. In fact, since our remainder is equal to the divisor, it means we could have divided exactly 1 more 88 into 528. So we should have picked 6. And if you multiply 6 times 88, you'll see that it's 528.